the next chapter. Now, a lot of what we do today will be review, like this first part. Just a function to begin with is a mathematical relation where each input has only one output. Now, in algebra, maybe you had to worry about ordered pairs. You would look for repeats in X that give you different Y's. You're not really going to get asked that this year. And you won't get asked just for the vertical line test either. But you may still need to use it in a more challenging problem. So the vertical line test, remember, it just tests to see if something is a function. And the way it works is, if yes, can connect 2 points on the graph with a vertical line then no, it is not a function. Kind of backwards. Yes, you can. No, it's not a function. And this should be pretty easy. This is review. Like, A, all these are just asking, hey, is this a function? A pretty much fails the vertical line test everywhere. No. B is a parabola. It's an x squared graph. There's no way I can connect any 2 points of this curve with a vertical line. I mean, it's just, it's not going to work. I can't do it, so yes, it is a function. C as well. I mean, there's no way. Yes, it is a function. D, a semicircle. Nope, there's no way. So yes, it is a function. E, sideways parabola. It fails pretty much everywhere. So no. And on F is a horizontal line. I mean, there's no way you can connect 2 points of a horizontal line with a vertical line. So it definitely is a function. Now, here's a new part. And this isn't really that hard. The horizontal line test. This is to see if something is what's called a one-to-one function. This is new. Now, a one-to-one function, first of all, it's got to be a function, which is why we just reviewed the vertical line test. And what it means, what the one-to-one part means, each output is only used once. They are all unique. Unique means one of a kind. I mean, maybe other than the word unique, they might use other language that means no repeats, used only once means unique, something like that. Number one, which of the following graphs illustrates a one-to-one relationship? So here we go. And the correct answer is number one, but I'm going to work backwards through them just to illustrate, to help you understand this. Choice 4 is a graph. But as you can see, I can connect lots of points with horizontal lines. Now, what that means, if you can connect the horizontal line, I don't know, let's pretend that this spot is 3 up. That means that one's also 3 up, which means you have a repeated output. So that's why the test for a one-to-one function is the horizontal line test. If you can connect any 2 points with a horizontal line, that means they got to have the same y value, the same height. And y is output, so it can't be unique. So that one fails. Choice 3, well, choice 3 is why we reviewed the vertical line test, because sure, this one looks like it passes the horizontal, and it does, but it can't be a one-to-one function because it's not even a function, because it fails the vertical. 2 fails the horizontal pretty much everywhere. 1, no way you can connect any parts with horizontal lines. It is one-to-one. Okay. 2 is which of the following graphs does not represent a one-to-one? Well, if you take a look through there, 3, absolute value V, ooh, what is that? An absolute value V fails pretty much everywhere. That one is not. 3, which of the following graphs is each input not paired with a unique output? So there's what I was saying. You know, they might not say one-to-one. They might use a synonym, something that means one-of-a-kind output. So basically, which one is not one-to-one? And as you can see, choice 2 down fails the horizontal line test a lot. There you go. That's not one-to-one. That was the first new thing. Hopefully that was pretty easy. Now, the top part of this is review from algebra. Function notation. Now, how this is pronounced is G of A. The function is G. The of A part means that A is your input variable. So it says G of A equals -3. Now those bars mean absolute value. Absolute value is always positive, unless it's 0. That's the only case. So just to recap here, G of A equals -3 times the absolute value of 2A. Find G of 2. All that means is, since it's a function of A, and then it says of 2, put the 2 in for the A. Substitute it in. Then basically this is order of operations. 2 times 2 is 4. The absolute value 4 is still 4. It's always positive. Then Negative 3 times 4 is negative 12. Number 2. Again, h of a. All that means is a is the input. So find h of negative 10, put that in for a. And you can absolutely just type that into your calculator if you want. If you do it out by hand, you got to multiply first. Negative 40 plus 2, negative 38. It's the same idea in all of these, but you know, maybe 3 is a little bit of a curveball. X is there twice, so substitute the 9 in twice. Again, you can just grab your calculator. Type that in, 9 squared plus 4 times 9. If you do it out, it'll be 9 squared first is 81. Then 4 times 9, 36. Add those, you get 117. Again, you can just use your calculator. 4. Put the 6 in. Negative 2 times 6 is negative 12. Negative 12 minus 3 more is negative 15. The absolute value of negative 15 is 15. You put negative 1 in, and you can just type that in, you get negative 2. Now, the next 3 are basically just the same thing. This is just review. It's basically just a way to make you do PEMDAS, or just pull out your calculator and type it in. Just, you know, what the point of this is. Let's take that number 5. You can write it like this. What the point of function notation is, I saw what I put in, and I saw what I got out. It's just a way to have a more informative notation. We don't need to go over the last 3. The next part is new. Inverse functions. Now, inverse functions, they basically undo each other. You put a number into a function, you get an answer out. If you take that answer, put that in the inverse function, you get the original number back out. A function and its inverse, they undo each other. Now the steps finding an inverse, and this isn't that bad. Steps are swap your input and output variable. Literally just swap it. I'll show you what it means in a minute. Then solve for the output. Now the last step is put a little -1. It looks like an exponent, but it's not really. It just means inverse. Okay. So number 9. Swap. Literally just swap. Like I said, this really isn't that bad when we first start out. Now solve for the variable, the output variable. I got to get g alone, minus 4. We're basically done. Just put that -1 on the output variable. We're done. All that -1 means is inverse. Now, I mean, you could reverse the order so it looks neater, but those are the same thing. And, you know, this should make sense. If the original function's adding 4, the inverse of add, the opposite add is subtract. There you go, and minus 4. Number 10, again, swap x and y. Get your y alone by adding 5. I can't combine x and 5, so I'm going to write x plus 5. Now I divide by 5, by that whole thing. And you can't really simplify that anymore. X is 1x. So, I mean, you could write 1/5 x to divide, plus 5 divided by 5 is 1. Could, I guess, have 1/5 x plus 1. No reason to. This is good enough. Stick the -1 on the y. There you go. Inverse. Swap your input and your output. Solve for w. Add that 5. Now that's w divided by 3. So to cancel out, the 3 will multiply. But just be careful. This is a binomial, so I got to use parentheses. I'll distribute 3n plus 15. Stick the -1 on it to mean inverse. That's all that means. 12. Y equals 6x. Swap x and y. Easy. Get y alone, divide. X over 6, stick the -1 on, inverse. 13, swap x and y. Add 9. Divide by 3. Put the -1 on for inverse. Now, 14, the only point on 14 has the g of n part. If it is written in function notation, just forget about the of n part for now. Don't worry about it. We'll tack that back on at the end. So forget that. If it's in function notation, forget about the function notation. Drop the of n or of x or of whatever part. Swapping, just like before, it's still nice and easy. Add 3. So like I was saying, basically now, just tack that of n part back on. That means inverse. Don't forget, it's not a real exponent. It literally just means inverse. And there we go. And that is the new part of the lesson. Now we'll continue with these functions next time, but that is it.